Hi, this is Kiran, your math chef for this hour from Bangalore. Looking at these beautiful flowers around me has given me an inspiration for today's math topic. Yes, colors. Today we'll see how we can use colors in math to solve some interesting math problems. Are you ready?
Let's start with a simple problem. So on your screen, you see an 8 cross 8 square grid and a domino. So the question is, how many dominoes do you need to completely cover the square grid? Okay, so we have 8 cross 8, that is 64 squares, and a domino covers 2 squares. So 64 divided by 2 is 32. That should be the answer. Let's check it out. Oh yes, 32 is the perfect answer. Let's move on. Now, what I've done is I've broken two corner pieces of the square grid. So this is a broken square grid. And the same question, how many dominoes do you need to completely cover the broken square grid? Well, let's use the same approach. We have 64 minus 2, that is 62 squares. And we have a domino that covers 2 squares. So the answer should be 62 divided by 2, that is 31. Is it not? Is that the answer that you also got? Let's find out. Oh, this happens to be a question for 1 crore. Okay, so how many dominoes are needed? Option A, 31. Option B, 32. Option C, I don't know, but it's possible. And option D is impossible. Hmm, now this is a little tricky. What do you think should be the right answer? What should we lock on? Remember, this is the question for 1 crore. How about using a lifeline? Well, let's take a 50-50 lifeline. Boom! The two wrong answers are gone and 31 is not on the screen anymore. We have just two options, C and D. Which one to lock? This is getting more tricky, but don't worry, we have a secret lifeline. Yes, the math lifeline. Let us see how math coloring can actually help us answer this 1 crore question. Okay, so let's get back to the initial problem. So we have a square grid, an 8 cross 8 square grid. The question is how many different ways we can color the square grid using just two colors. Okay, so one option is to color the first row with red, the second row with yellow, the third row with red, the fourth row with yellow, and so on. But is there any other way to color? Yes, let's see. Wow, this looks like a chessboard. Yes, so what we have done is we have colored the diagonals alternatively with yellow and red. Now, and an interesting part of this is, can we cover two squares of the same color using one domino? If you use this coloring, you can see that it's impossible to cover two squares of the same color using a domino. So if you place a domino anywhere on the board, horizontally or vertically, it will always cover one yellow and one red. So in the square grid, we have 32 red squares and 32 yellow squares. So obviously, if we keep 32 dominoes, it will cover 32 red and 32 yellow. So 32 seems to be the right answer. Now let's look at the broken square grid. So here we have used the same coloring, but let's count the number of red squares and the yellow squares. Do you think they are equal in number? Yes, they are not equal in number. So how much ever we try, it's impossible to cover this broken grid with dominoes, because every domino covers one red square and one yellow square. So if we are able to place dominoes here, they should cover same number of red and yellow squares. Since this grid does not have the same number of yellow and red squares, the option to select option D. Wow, congratulations! We have won 1 crore worth of math fun. Was that fun? Okay, let's move on to the next puzzle. Dominoes and a rectangular grid. So the question here is, How many dominoes do you need to completely cover the rectangular grid? So we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. An 8 cross 7 rectangular grid. Now, what would be your answer? I think that was an easy one, but let's try this now. So we have broken two corner pieces of this rectangular grid, and the question is, how many dominoes do you need to completely cover the broken rectangular grid? Do you think it's impossible, or do you think it's possible? Okay, the next question to win a crore again. How many dominoes are needed? Option A, 27. Option B, 28. Option C, I do not know, but it's possible. And option D, it's impossible. Well, this time, I don't think we'll need the 50-50 lifeline. It should be 27, right? So in this case, it is actually possible to completely cover this grid. That was fun. Now, time for some exercises. Can we completely cover a broken rectangle grid of any dimensions? So try these ones below. 8 cross 6, 8 cross 5, 6 cross 6, and 5 cross 5. Well, if coloring is fun, math is fun too, isn't it? Now, do an interesting puzzle to end this session. This is called a catch-22 puzzle. So let me read out the puzzle. You can enter the palace that you see here on the left side via the room marked in here, and exit the palace only via the room marked out here. So you can enter here and you can exit out from here. The goal is to enter the palace and capture as many gold coins as possible and exit out safely. You can move from one room to another via the doors along the inner walls. So we can move from here to here to here and so on. In other words, we can move from one room to another room horizontally or vertically, but never diagonally. So we can never move in this way, right? We cannot move from here to here. Now, once you leave a room after collecting the coin, the room gets locked and you can never enter the room again. So in other words, you can never enter the same room again, right? That's the rule. And the objective is to collect all the 23 gold coins. So you can see that there are 23 gold coins. You need to enter here, collect all the gold coins and exit out safely. Is it possible? Can you try it out? And the big question is, how is this related to math coloring? Okay, that's for you to figure out. I hope you had lots of fun. Thank you so much. And here are my coordinates if you want to contact me and reach out to me for any questions or discussions. This is my email, my Twitter handle, my Instagram handle, and my websites. Okay, so thank you so much and have a great day. Have fun with math.